Okay, here, as promised, is going to come the proof of circle theorem 1. So circle theorem 1, or that centre equals to edge, says if you have this configuration, you've got the centre of the circle. The angle at the centre, that one there, is twice as large as the angle at the edge. How do you prove such a thing? Well, we want to show that it's always true, no matter exactly how the diagram is arranged. So we'll need to dive in with some algebra. But the key idea is to draw a line from the angle at this edge to the centre and then carry on and extend it. What's just happened is we've split our angle at the edge into two smaller angles. I'm going to call this one x, and I'm going to call the other one y over there. And now we can use all the isosceles triangles that we've got because of all the radii. There's a radius there and a radius there. So this angle down here must also be x. That's great. And now let's look. Two x's plus this sort of dot make up 180, but the dot plus this angle here also make up 180 because of this straight line. So this one here must be 2x. You can actually sort of chase that through by figuring out that dot is 180 minus 2x, and then do a subtraction there. Be careful with your minus signs. Exactly the same thing on the other side. There's an isosceles triangle here. That radius and that radius mean that this is angle y. Okay, but that little cross there then, what two lots of y plus cross is 180, but this angle plus cross is also 180, so this is 2y. So what we've just discovered is that the angle at the edge is, let's look at it, it's x plus y. And the angle at the centre is 2x plus 2y. So it's exactly twice as big no matter what x and y are, no matter what the angle at the edge actually is. Also, just very quickly, exactly the same argument, exactly the same proof will work in the other slightly different configuration where your angle at the edge is a large angle, an obtuse angle. So this one here is kind of big, but again, exactly the same thing. Line from the center, from the edge to the center and through, splits it up into x, which is the same as x over here because of this isosceles triangle, and y, which is the same as y over there because of that isosceles triangle. So then you get dot and 2x, so dot plus two lots of x is 180 for the triangle, dot plus 2x is 180 for the line, and cross plus 2y is 180 for the triangle, so this must be two lots of y here. So again, you have exactly the same conclusion. I'll just slide it in. The angle at the edge, the angle at the edge is x plus y, and the angle at the centre is 2x plus 2y. But again, you can see that the angle at the centre has got to mean the one on the other side of the quadrilateral.